Thank you for those kind words. I have to say I hardly recognise myself. And thank you everybody for making the effort to attend under such difficult circumstances. Let's hope that next year or the next set of proceedings we will be able to attend in person. So I was delighted and honoured when the request came from the OSI 21 committee and Dr. Bashir to present here today. Then I had a bit of a dilemma. What on earth can I present on once you've been living and working in the industry for such a long period of time? So I thought, why not set the scene for the rest of the conference and highlight where we've come from, where we are, and where we're going. And this would also provide me with a vehicle to shine a spotlight on the highs and the lows of our industry sector. So I thought the best way would be to split this up into a pictorial history for you, the audience, followed by a slightly more serious section on the roles of all of us involved, how we can better our ways of working, and then a quick glimpse of the future. Over the past 3 decades, we've seen our industry move forward in leaps and bounds. And with the rest of society, this can mainly be attributed to the advances in computing and miniaturization. We must congratulate those equipment companies who have been bold enough to commit time and money to the development of better data acquisition, processing, and interpretative systems. An example of how our computers have developed over the past 30 years is a comparison with the 1991 Space Shuttle and the Xbox sitting in your living room that your kids are playing with all the time. The first computer, or the flight computer on board the shuttle, had less than 3% power as the Xbox. And not only that, the wiring for the shuttle weighed over 3 tons. So let's look at the evolution of offshore site investigation. In the eyes of Darwin, things could look a little bit like this. But 30 years ago, what were geophysicists, geologists, geomatic specialists, and geotechnical engineers using their skills for? Or as I like to call them, the 4 Gs. And for ease, I'll be using this acronym through the rest of the presentation. The use of the 4 Gs was somewhat restricted to oil and gas and engineering projects. In the oil and gas field, our skills were mainly used for rig positioning, developing shallow soil profiles, and the positioning of pipe lays. Civil engineers would sometimes use geophysics to fill in the gaps between boreholes to create an image along an alignment of a bridge or a tunnel, such as that of the English Channel. However, civil engineers still related geophysics with a level of skepticism, treating it as a black box technology and possibly not to be trusted. I often came across engineers who would state, "I used geophysics once and it didn't work." When asked why not, I was quite often told that engineers did it themselves, and they did admit that they actually didn't know what they were doing. Then other industries started to see the benefits of site investigation, especially the marine mineral sector. Sand and gravel extraction companies could now use geophysical methods to evaluate and establish tonnage of deposits. Placer minerals could now define potential mineral-rich layers and calculate overburden stripping rates. And exotic minerals such as diamonds not only had the need for better mapping tools, they also had the cash to develop their own systems and methods. As detection techniques became more refined and equipment, due to advanced processing, worked at much higher resolution, site investigation could now be used for more subtle targets such as UXO and archaeological features. In European waters, for instance, any maritime wreck is now considered a war grave and must be treated with greatest respect. Around the 1990s, the marine environments saw an explosion in telecommunication activity. Up until this point, the establishment of a cable route, clearance and laying of cables was in the realm of a select few, known as the white ship skippers. Long-standing captains of cable-lay ships who were set in their ways and tradition. with perseverance from a number of companies convinced that the cable sector was due for modernisation, and there was a period of technological transfer from oil and gas, resulting in the 4Gs becoming an important part of any cable project. And then for the past 10 years or so, we've seen a newcomer in the sector, the renewables. Originally developed by large power companies and later upstart investment houses, the offshore wind market has blossomed. Not only wind, but tidal, turbine and wave devices are all competing to be the best source of electricity. To continue describing renewables needs an entire conference on its own, but suffice to say is this sector has grabbed the 4Gs big time. So let's move on and look at other changes in the offshore site investigation world. And we'll start with the recording platform, the boat, or as contractors would say, the vessel. Over the past 30 years, we've seen a variety of vessels used for site investigation. These in many cases are converted fishing boats, fishery protection vessels, ex-military vessels and ex-research vessels. I expect some of you recognise some of these and could tell a tale or two. Some were good, but many can only be referred to as old dogs. This tug down in the bottom corner here was my first boat, the Sea Trojan, although I expect some of you think my first boat had oars and shields along its side. Conditions on board these vessels varied from downright diabolical through to very basic to reasonably acceptable, but at no time did the site survey vessel reach the level of luxury attributed to that of the seismic exploration boats. As time has gone by, the global fleet of site survey vessels continues to age. Some have been scrapped, some even have sunk, and others retired never to be seen again. The global fleet began to have better vessels, and Pugh has to be commended for building the first fleet of bespoke site survey vessels. Others have followed, and the vessel in the bottom centre here is Ireland's latest for the Marine Department, which has recently been launched. Not only do the vessels look the part nowadays, they are comfortable and their crews may have excellent accommodation and facilities. As with the vessels, we've seen great advances in offshore data recording equipment. This has been driven by miniaturization, the ability to require and record larger data sets, and tow fish that can carry multiple payloads. I'll quickly flick through a range of equipment, highlighting the advances made. The humble and much misunderstood magnetometer has come of age. Originally used on a hit-and-miss basis to find large metal objects like wrecks, we can now record magnetic fields in up to 3 planes. Sensitivity and range has been improved, resulting in much smaller ferric objects being detected. For instance, this grey object is a magnetic response from a telecom cable that passes over an igneous dike. Prior to gradiometry, magnetics and the magnetic signature from the dike would have swamped that out of the cable and it would never have been detected. One of the suites of equipment that has greatly benefited from advances in computerization are the sub-bottom profilers. Chirps, pingers, sparkers and boomers continue to improve with greater depths of penetration and resolution. Just remember that a single sub-bottom profiler will not give you all the answers, and certain systems best suited for different geological conditions. The digital system has also improved from 12 channels of data up to 96 and even more, being very common nowadays. Air gun cycling is proved, but old compressor systems can still let us down. So if exploration seismic can shoot 3D, then why cannot this apply to site surveys? Well, it can, and it has developed by several companies over the past 10 years. P-cable are being used to incredible effect, providing excellent 3D data cubes over proposed well sites. We have several papers on the P-cable, so I'll not steal the other presenters' thunder and leave it to them to explain this methodology in much greater detail. Marine resistivity, developed by the Belgians, it came, it conquered, and then it's disappeared again, but it will return. Excellent for dredging and delineating sediment type for dispersion, should always be used with another sub-bottom profiling system. And as I say, this system will certainly return and be part of our armory in the future. Scanning sonar. It's a bit of an exotic tool developed by the American Navy for the inspecting of submarine hulls. Now it's being used in conjunction and merged with scanning laser to provide below and above waterline imagery. The system all provides live images and it can be used in very murky, opaque water conditions. The advances in multi-beam must surely make it one of the champions of our acquisition tools, purely due to the high volume data sets resulting in stunning images of the seabed and features on the seabed. This system is slowly taken over from SideScan, but will never replace it. So I hope that has given you a taste of where we are and how equipment has progressed and technology has improved. And it's definitely one of the industry's highs. Now let's change gear and move into a more serious side of the presentation and flag some of the lows. I'll let you read this slide, but in summary, why do we do site investigations? Is the rig, the jacket, the pipeline, the cable, or the pile in the right place? Secondly, is the said structure a threat to human life? Thirdly, will the structure be and operate, when it is in operation, a threat to the environment? Fourth, does it meet legislational requirements? And 5, can it be insured? And what happens when we get it wrong? I want you to hold these images for a while in your mind and keep thinking about them whilst we carry on with the rest of the presentation. We have to ask, what is the cost? The cost of a jackup rig is around 175 million US. The cost or loss of a drill ship, about 140 million US. Destruction of a telecom cable comes in at several $1 million a day. The damage to the environment, priceless. The loss of human life, well, you tell me. So, following that stark glance at reality, what are the roles of the individual groups when it comes to site investigation? Please note that the comments that have followed are based on over 35 years of experience. I'm an independent and I do not take any particular side. I am, however, concerned that lives continue to be lost and it can easily be averted. The contractor's primary objective is to provide the client with a fit-for-purpose data set, interpretation and recommendations that will allow the client to make an educated decision on how to proceed with the project. This is achieved through good practice and under safe conditions to all those involved. The contractor utilizes the latest and often very expensive data acquisition system for the benefit of the operator or client. The contractor is also the primary source of our future 4G personnel, taking on graduates and training them to the best of their ability. I now have to ask, what does the operator require? What is the pinnacle of the survey? The answer, the final interpretation and report. This is where as much effort needs to go into the project as having the greatest vessel sitting out there on the sea. After many years, I still come across final reports that are questionable in quality. I still see geophysical and geotechnical data that's not being combined and correlated. And why is this happening? My observation is that all the budget is now being given to the operation of the boats, and the smallest sum is being left for the final report and to a junior with little or no guidance. I have to ask the contractors to start putting in sensible values into tenders for final reports that will allow senior interpreters to mentor juniors with interpretation and reduce the areas of risk and identify alternative locations for structures. The responsibility is not only with the contractor, but it's also with the operator and client. The role of the consultant. This should be an easy one for me, like falling off a log, some would say. I've been doing it for far too long now. In many cases, the consultant has come up through the services of a contractor, and they are what we call poachers turned gamekeepers. They know the tricks and they know the corners that could be cut, and they're there to guide the contracting staff how to do things a little differently. The consultant acts as the go-between, representing the client, but working with the contractor to achieve the best results possible. This role has greatly changed over the years. Operators now expect the 4Gs to be HSE experts, and more time can be spent in meetings, answering calls and filling in HSE documentation than actually doing their prescribed job or making certain that data is fit for purpose. If HSE is so important, stop cutting corners and appoint an independent HSE expert as part of the crew. In addition, consultants find their time more and more being used teaching young personnel rather than hitting them with a stick. We don't mind doing this, in fact we enjoy it, and it's great to see youngsters come along and learn from those. And this will always happen and benefit both contractors and the operator. The contractor or client has the primary objective to meet, and that is to have data collected so that its structure is in the right place, it's safe, it's not a threat to human life or the environment, and it meets legislation and insurance requirements. The operator then passes this responsibility to the contractor and expects the consultant to police the work to be undertaken. The operator expects the contractor to work within its own, as in the operator's HSE system, and to industry standards and meet contractual obligations. The operator should also ensure that the contractor and the consultant are treated fairly when it comes to fiscal issues, and this audience brings me nicely to a major low that has insidiously crept into our industry over the past decade. Here we have a simplified workflow of a potential contract, typically seen within our industry. It may not apply to all clients, and to some it may not apply at all. But it starts off with management identifying a requirement. Specifications are written as a point of reference. Vendors are sourced. A potential cost for the project is established through market surveys, and then contracts are drawn up. These go to tender. They then follow clarification and tender evaluations, and then you have the tender award. However, over the past decade, we have been witnessing an ever-increasing influence of the procure department over final contracts. To those on the outside, it appears that the accountants are now king, and to save $1 and cynically to enhance the KPIs, they're forcing contractors' prices down to the point where corners are being cut, and the HSE procedures dictated to from the operator to the contractor are now having to be ignored, and these shortcuts are even being highlighted by the incumbent operator. I hear the sucking of teeth and deep intakes of breath, but unfortunately, this is the truth. Only last week I was informed by a contractor that after contract award, the client's procurement department approached them not only once but 3 times, demanding a cut in the rates. This resulted in the contractor admitting that nothing was left in their budget to allow for vessel maintenance. So I've given you here 2 potential scenarios that we can see that the influence of the procurement department. First scenario, and that can easily be summed up by the saying, buy cheap, buy twice. Then we have scenario 2, the one that we continue to see. So I have to ask, when the proverbial hits the fan, will we ever see the head of procurement standing in front of a judge proclaiming he is guilty? I think not. Is there a solution to the situation? Yes, I believe there is. It's time to shift procurement's function from short-term cost saving to a more holistic objective that includes strategic supplier relationships. Consider giving preference to longer-term cost efficiencies and working with the contractors to identify opportunities to develop more innovative products and services. Please, gentlemen, let's start seeing this. So if you'd forgotten the earlier images, here they are again. I'm really trying to make a point here. I'll now get off my soapbox and let's have a more light-hearted look at our future. To be honest, the future's already with us. AUVs have now reached a high level of maturity where we see huge fleets of these things sitting in vessels ready to go out and collect data. The increasing technology and the size of battery and mission lengths have increased. Payloads have increased, allowing for greater sensors and deployment. And we're now seeing not only battery-powered but sea-powered gliders collecting data not only over days but over months. And then we have the next step. Drone technology, small fleets of autonomous vessels departing a mothership and collecting vast swaths of data in greatly reduced time. Remote vessels will continue to be developed, allowing for detailed inshore surveys or in toxic environments such as ponds, mine dams where you cannot put human beings in, and this will greatly reduce our HSE concerns. Advances in technology resulting in cheaper and safer data collection, and this is obviously a big up for our industry. And where will all this be used? We're seeing greater use of our seabeds and our oceans. We're seeing aquaculture, we're seeing mining, we're seeing renewables, all of which need detailed pictures of the seabed and below the seabed. So I think our industry will develop greatly over time and be with us for quite a considerable few more decades. And who knows, just around the corner, our survey vessels could start looking like this. And finally, I'd like to acknowledge the OSI 21 committee for allowing a bit of an indulgence here. The following companies for their images: Dr. Fiona Fitzpatrick, who you may know for suggestions and vetting my abstract, and finally Jeremy Tung, yes, we all know Jeremy, for images, inspiration and friendship. And that just leaves me to say thank you for your time. Thank you.